lunar mobile laboratory to the moon, which would have had a pressurized cabin where 2 astronauts could travel on the surface for as long as 2 weeks and hundreds of miles distance. Now, the weight of this vehicle would have been 8,000 pounds. A simplified open version of this concept called the Lunar Scientific Survey Module, shown on the lower right side, was an open version of this same concept. Now, they both were too heavy, and they would have required a separate Saturn V launch to be delivered to the surface prior to the astronauts landed at the same location. Now, NASA recognized very soon that they cannot afford such a dual launch and the expensive Saturn rocketry and delivery system, so they have given up on this grandiose exploration vehicle. And in a sense, they have given up on lunar surface mobility altogether. Their main objective then was to, as President Kennedy postulated, land man on the moon and bring them back safely, without any capability of going around beyond just walking around the landing site. Now, we at General Motors Research haven't given up, and on in-house funding, we were looking at possibilities of putting a rover large enough to carry 2 astronauts within the already designed lunar lander. And we built a scale model of such a concept, which is shown on the lower left side. When we asked NASA what space would be available on the lunar landing vehicle, they identified a triangular envelope at one corner of the 4-legged lunar landing module, as shown on the left side. And so our big problem was how to put a vehicle which is able to carry 2 astronauts and their equipment in a triangular-shaped storage envelope, which was about 60-inch tall, 72-inch wide at the base, and 40-inch deep. It's something like putting a Jeep into the back of a station wagon. So what we did is designed a folding capability for this vehicle, folding the front and the rear part of the chassis 180 degrees, then folding the suspension and wheels to 45 degrees, so it would fit into this triangular-shaped envelope. Of course, when taking out, everything had to be unfolded and set down on the surface. This is a front view of the finished lunar roving vehicle prior to delivery. And another problem we had to overcome, is the tight delivery schedule. Once we persuaded NASA to go ahead with such a vehicle for the lunar Apollo program, we had 18 months left to design, develop, and deliver the first operational vehicle for Apollo 15, which was to be launched in '71. The vehicle looks deceptively simple, like a dune buggy. Sometimes they even refer to it a moon buggy. However, in sense, it was a very sophisticated spacecraft on wheels. It had to satisfy the stringent requirement by NASA for manned spacecrafts, with all the reliability, quality, redundancy requirement prescribed for manned systems. It was equipped with a color television camera, which is with the gold foil enclosed. Its antenna, which is an umbrella-type umbrella directed toward the Earth. A voice communication antenna, by which they had a direct communication between Houston and the rover. The seats provided for the two astronauts were almost like garden seats, very lightweight, and could be folded down so that the vehicle chassis could be folded over. The rear view of the same vehicle is shown here. The scientific equipment and geological tools were mounted on the rear of the vehicle on a vertical panel, which was erected after the vehicle was deployed. You can also see that all the wheels are covered with a fairly large fender. And this was very important because in the 1/6 gravity of the moon, the thrown up sand-like material would have deposited on the science equipment as well as the astronaut suits, which would have affected their thermal control. To how important these fenders were was evident on Apollo 17 program, which was the last of the Apollo flights, where inadvertently a fender extension was broken off. And as they started moving, they realized that the dust thrown up was depositing on their spacesuits. So they were clever enough, they improvised and used a plastic map which was provided for their sortie, and clamped it in the place of the broken fender, and they could continue their 3-day exploration with it. This shows the overall characteristics of the rover. It was a little over 10 foot long, 6.5 foot wide. On Earth, it weighed 460 pounds. But on the moon, 1,600 pounds. So the payload to weight ratio of 3.5 to 1 was an excellent number, unheard of for Earth vehicles, except for bicycle. On the moon, however, fully loaded, it weighed only 266 pounds, which was to our advantage in designing the power system for moving this vehicle along. The maximum speed was 10 miles per hour, the range 75 miles, a turning radius 10 foot by turning both the rear, front and the rear wheels. It could actually turn around within its own length. It could climb soft soil slopes of up to 25 degrees and had a static stability in both directions of 45 degrees. Now I tell you something about the main components of the rover. This was an all